Alright, good afternoon. Just wanted to do a little bit of work here with the scope again. Wanted to show you compressional beam thickness testing and some of the stuff that goes along with that. Then we're going to look at dual element thickness testing. Then we're going to look at a delay line. Then we're going to calibrate up to a shear wave. And then we're going to look at that calibration on a DSC block. Those are kind of the videos that we're looking at this week. So, first off here, just wanted to go back through the scope, kind of take a look at some of this stuff. We are right now looking at an RF signal. Okay, so let's go figure out what that is. Which you already know, there's 4 types of ultrasonic signals, and just so you can see where we're at, I just have my transducer on a 3/4 inch step of a 1 inch step wedge here. So there's 1 inch. You can read it there. It says 0.750, 0.500, 0.250 down here. 250, 5, 750, 1 inch. Okay, so let's just take a look at those. Here's the 1/4 inch. 1/2 inch, 3/4 inch, 1 inch. Alright, so it's close to calibrated. I just basically want to show you right now the differences between those 4 types of waveforms. So there's RF, there's the negative half wave, which we had said before. If you take the RF, the negative half wave is going to be these 2 bottom signals. So if we go to negative half wave, you see 2 spikes. Whoops, got a little coupling on the screen. But they are turned upside down compared to what they were before. So there's the 2 spikes, there's the negative half wave, there's the positive half wave. Okay, let's go back and look at that. 1, 2, 3 peaks. 1, 2, 3 peaks. Full wave, now it's all smashed together. Sometimes that looks better, sometimes that looks worse. It just depends on what it is you're actually looking at. So I'm going to say we'll stick with full wave for now. Not necessarily the best looking signal, but at least we can see what's going on. So let's kind of calibrate this screen here. Let's say first thing we want to do is go to a 4-inch range. I'm just arbitrarily picking 4 inches for fun. So I'm going 4-inch right there. Then I've got steel, so I would pick my velocity. Okay, and I can just roll through a number of velocities here. 233 or 233,000 inches per second is what we want. That's what that number is. Here's a display delay. I'm going to take that back to 0. Alright, there's a probe delay. I'm going to leave that at 0 right now. Go to pulsar. If I go high damping, I have that signal. If I go low damping, it's going to get bigger. Okay, as you can see, damping is just that. It dampens the signal. So there's high damping, low damping. Okay, so let's go low. High power, low power. High power, low power. So I'm going to say low power sounds good. Dual, if I turn the dual mode on, that's telling it I have a dual mode transducer, which I don't. So I want to leave that off. This pulse refresh rate, or this screen refresh rate here, this PRF thing, this PRF is telling us that if we pull this off of here, that's the refreshing rate of the screen, okay, which is not very fast. So you can see what I'm looking at here. Okay, I pull this transducer off, put the transducer on. It takes a minute to get it all situated there. Okay, so we want to run that up as high as possible, so we get as close to real time as possible. Whoops, there's 8, there's 10, sorry. So now we're on the 1 inch thickness. Look at it here and then I'll move it. 1 inch thickness, okay? There's our 1 inch thickness, 1/2 inch thickness, or sorry, 1 inch, 3/4 of an inch, 1/2 an inch, 1/4 of an inch. Since we're going to be calibrating to 4 inches of range, we're going to want to mess with the 1 inch and 1/2 inch steps. Okay? So now we need to see 4 inch range, steel, there's my delays, I want that at 0. We need to get this first signal to 25, next signal to 50, next signal to 75, last signal over here to 100%. And again, that doesn't look too pretty because we have such a small step wedge and a pretty good sized frequency transducer. So I'm going to go to something that's 1 inch thick still, but it's a little bit bigger, so it's going to clean up those signals. So now we're cleaning up those signals. We're still on a piece of steel here. I just went to this angled block is all. Okay, it's still 1 inch thick. So there. Now we're close. We're 20. Let's give it some gain here. We're pretty close to 25. We're a little past 50. We're past 75. We're past 100. So we're going to do that with the fine range or material velocity. Okay, I'm going to just move that a little bit at a time here. I'm just bringing that in, and you see this back signal over here moving in. If I just keep going, I'm going to keep pushing it in, but I don't want that. So I want 1 inch, 2 inch, 3 inches, 4 inches. Give it some more gain just so we can see what's going on here. Okay, I'm going to roll that back. Whoops, wrong way. Alright, there's my 4 inches right at 100%. Okay, I'm pretty close to 75. I'm pretty close to 50. And I'm pretty close to 25. But let's take this delay, push everything over just a little bit, just because I like to. So now we're right on 50. 25 is still good. 75 is okay, and we're pretty much right on 100 there. So I just pushed the delay over just a little bit, not enough to really hurt us, but just a little bit, so that way we could see what was going on. Now, let's bring a gate into the equation. Okay, and a gate is just that electronic signal. So I'm going to turn the gate on. That's a positive gate, that's a negative gate. They look the same. That's okay, so I'm going to leave it on a positive gate. I'm just going to gate start, meaning I'm just going to move this thing. Okay, I'm just moving it. Now, we see here that our signal, it's popping up here, SA, is telling us it's right at 1.035 inches. Okay, I have a gate start of basically 3/4 of an inch, gate width of 9/10 of an inch, and then the threshold's right at 50%. Okay, so I'm going to leave that over there. It's telling me it's right at 1 inch basically, but I want to get that a little closer if at all possible. So I'm going to take my delay here, my display delay, bring that back to 0, and I'm going to take my probe delay and move it over here. Okay, if I wanted to get this to 1 inch, which I can do, okay, I pushed it over quite a bit. So I'm pretty close, but I'm a little off here now. So I'm going to go back to my display delay and drag it back a little bit. Okay, so now if I go over here, that knows it's pretty much 3/4 of an inch. Okay, I'm outside of my 1/2 inch, so I need to take my gate back over here. So now I'm in it. Alright, and if I went to 1/4 of an inch, there's my 1/2 inch. It's not necessarily right on. Back to my 1 inch. It's not perfect, but it's close. Within 5/1000ths isn't horrible for thickness testing on a regular old scope here. But I could take my velocity now, crank that back out, and all I'm doing here is just basic calibration stuff. So I'm just messing. Okay. I'm just piddling, really, that's all I'm doing. I'll push that in a little bit. Okay, there's 1 inch. 3/4. I'm getting a little bit farther off all the time, which is okay, and that just means that I'm not calibrated where I need to be. So what I need to do is take this back all the way to 0. Going the wrong direction. Take that all the way to 0. And that brings me back to where I should be. Okay, so there's 1 inch. 3/4 I'm still off. Still off. Still off. Alright. So that means I'm good with the 1 inch. 1/2 inch is not so good. And 1/4 inch is not so good. So I would just take and continue to mess with this. Bring that back to 0, and I'm going to push this over now. Okay, but you see here how I'm on my display delay, all I'm doing is moving everything. Okay, and it's still giving me the same readings. That's not what I want. I want to be back here at 0, where I have my readings again, and I need to push everything over, okay, at least in some aspect. So I'm just going to do that again with my probe delay. Pretty close. Okay. Not too far off. Not too far off. Okay, kind of, there we go. And then I need to push my gate over a little bit. Oops. Put it over there where it needs to be. We're about 10 thousandths off. So we sat here and piddled with it for a while. We could get it right where we wanted it. We're not necessarily perfectly right on, but we're not necessarily so far off that we can't use that. So now we see some numbers. Okay, numbers tied to it. But anyway, we still want to be paying attention to these signals. So there's 3/4 of an inch. There's 1 inch. Okay, there's 1 inch again. So anyway, just a little bit about compressional wave thickness testing. Again, any questions, any problems or comments, you're more than welcome to call me. I'm going to bring this down to 1 inch. Just one last little bit here. I'm going to take my delays back to 0. Okay, now my delays are at 0. Push everything over just a little bit, just for fun. Okay, go to a 1/2 inch. I'm right on a 1/2 inch. Go to 1 inch. I'm right on 1 inch. So I'm right where I need to be. Cool. All I did was change my range and brought my delay down a little bit. Anyways, again, questions, comments, concerns, feel free to call me, contact me, anything like that.